Start streaming. Good day, folks. Hope everyone is doing okay today. Just a progress update on everything here. People I noticed were asking about the peg cells here, and before I get into that, I'm really happy to announce I finally figured out how to actually save the archives from the live sessions because I realized not a lot of people see the live sessions, and there's a lot of interesting conversations that get done in the live sessions, and I wasn't getting the people unless you go there specifically. You don't see them essentially. So all I had to do was go into the editor and save as new, and then it actually puts a copy of the videos. So from that point on, I will be putting a saving the live sessions so people can view them better and interact, because I was getting a little bit annoyed. I was getting a lot of interaction in the chat, and then it's like, well, a lot of that, people don't see if they don't get to leave regular video comments, the regular YouTube format, essentially. So finally, I guess I was an idiot for being the last guy to figure out how that actually all works. But that's YouTube for you. It's not obvious, but it was there the whole time. So with that said, I did realize people still talk about the PEG cells, the power cells I was able to develop a while back. I haven't been doing a lot of experiments with them lately because, as you've seen in my previous videos, I actually have, if you're interested in those, an actual playlist just power cells. So they're all in there, all of the observations I've made. And there's a lot of interesting, if you want to experiment with as close to a pure potential as you can, this is essentially it. Very, very minute amount of current comes out of these things. So it's actually been a bit of a challenge to try and figure out, okay, you can get up to a volt or so per cell, but what can you do with it, right? So it's nice to say on paper we want to have a pure potential to play with, but when you actually have it and trying to actually do something with it, a bit of a different story. But of course, what most of us already know is one feature is very good at charging capacitors. It'll charge a capacitor. May not run a light or anything like that, but it'll charge a capacitor. So if you can discharge that capacitor, you actually get amps a second. Now, if I had the equipment, if I had, my way, and money wasn't a problem, I would get some very professional equipment if I'd want to carry out in this direction. But there's just so much out there, you got to sometimes put things aside and move on, right? But let's say I'd be 100% dedicated to these PEG cells. The next step would most likely be actually getting some sort of nanoscale, maybe even UAmp meters and such, lab grade, so I could actually measure exactly how much of that near zero current the PEG cell, like if you're going to charge a capacitor with it, I want to know how much energy from the PEG cell actually reaches the capacitor versus how much it discharges, right? To actually do the math, right? It's one thing to say that, the capacitor can convert that back to amps a second, but if you're slowing down the process, so instead of having a steady curve and you chop it up to amps a second, it may end up being a more intensity spike, but if you were to average it out, you may end up with the same thing. I believe there are different mechanisms in the capacitor itself that sort of work against that principle. For example, one that's really obvious is the temporary alignment of the dipole inside of the capacitor, also known as the memory effect. Once you start, Bedini actually exploited that as well. So between that and their ability to once pulse to be able to interact with external fields, I think it's a mix of 3-4 mechanisms altogether that when they work, plus your zero current trigger, then perhaps I believe that as a repetitive feature, there could be more output that comes out of the capacitor. But of course, we must understand and separate the local energy sink and the global energy sink and accommodate for both and figure out which one is local and which one is global. But again, to do that and to confirm those findings, I would me or anyone else would really need to do that next step and actually take the measurements. Because just from observations, I know that really interesting things happen. For example, I was able to, with a microwave transformer like this one here, with very little current, with the help of a reactive power supply. I have this on a video, another charger somewhere, I forget what it was called. But what I did essentially is I used this to charge a chain of capacitors around, I think it was, actually it's right here. I wrote it down because I forgot what it was. Right here. So I was feeding this with a high voltage zero current transformer. It took about a second to load these capacitors, and together I was getting 28 UF at 1 kilovolt. But when these capacitors here were all charged, and I discharged them, you get a big paff, right? Waited 15 seconds, paff again, right? So at that point I shorted it out, like for 1 minute, completely shorted out. Took that off of there, waited maybe half a minute or so, paff again. So for about half an hour it kept doing that. So I understand about the memory effect, but what happens is I must have let it there for over a minute, completely shorted out on a thick cable where you'd see zero, and even at a minute it was able to bounce back. So in part, I believe, taking advantage of a system like that with capacitors being triggered with zero current with our PEG cells might do the trick somewhat, some way. But again, this would require some very specialized equipment to verify, and I must move on to other interesting topics, but people like the power cell, so I want to try and explain as much as I can. So speaking of power cells, here's one here that I made. This is going to be a year old soon. And I'm going to measure it right now, and as far as I know, it still works. No corrosion or anything. Puts about a little over half a volt, this one, because I didn't have the magnesium, so it was just a tin, essentially. But there's the carbon felt here, and there it is, 0.57 volts. I can show you this from. I'll try and put in the carbon there. You see the meter. I don't know if you can see that, 0.56. That's pretty cool, So this is going to be a year old. Puts out about the same. I think I had like 0.7 when I first built this. It was always a little bit lower because I didn't have the, I ran out of magnesium. But I still kept it because it was a good batch. This is the one that I used a little bit of copper oxide powder in it. It really solidified the peg, it's like a brick. And this is something else I built here. It's not a peg cell. I just wanted to experiment with the John Hutchinson cell. This is exactly to his specification with his crystal recipe. And it works. But the issue I have with this is this material keeps expanding, and eventually the pipe is going to split, right? But as far as I know, if I do a reading on it, there it is, 0.5. Still puts out. So it was just a pipe with the, when I had it all mixed together, it was still hot. I was able to pour it in there and let it. The recipe I don't have off my mind there, but it's easy. Just look up the John Hutchinson power cell, and many others have replicated it as well and have all those details. I just don't want to start saying stuff off my mind here. But yeah, it's the Hutchinson cell. It works, but I didn't like the idea that, the crystal isn't very stable, right? The peg, as you can see, doesn't do anything after it's dried out, which makes it, I think, more stable. And there's unique properties of the peg as well. So I never tested, in details if the polarity would invert with the Hutchinson cell as well. Um, Maybe I'd do more experiments with this one day, but just putting it out there, since people like power cells a lot. So yeah, I'm just gonna go here and read if there's anybody here and what they're saying. Yeah, basically half a volt, no amps. Well, of course, there's a minute amount. It's electrostatic, so you're dealing probably with like less than a quarter of a U amp or something like that. But it's a very minute amount. Um, I think I've measured on my meter a milliamp or so. Um, but it's not consistent, It's like when you first it has to regauge itself. So that's why they work better when you pulse them. And I had a cell stack actually. It's on one of the videos. Can't find it right now because I cleaned everything up. But it's basically a nice tray with all individual peg cells, and it puts out about 12 volts. And that one was running clock modules, little motors, LEDs, without a joule thief circuit, to help it. So it was just it was raw right off the peg cell. But I think my conclusion is it's not a thing to use natively to try and even get a few milliamps. It's best used for those other features that I demonstrated, like the polarity inversion, the using them as electrodes, because the PEG material is essentially a cold temperature version of an electret. It has the features of an electret, but it works at low temperature instead, which is really interesting. And you can look that up in the PEG composition. Some institutions and universities are actually studying the features as an electret and a special kind of an electret. It's not like the wax that needs to be heated very hot. This electret will activate at room temperature. And being its own dipole, if you understand, that's part why the PEG cell is able to, as a capacitor, charge itself essentially. And people have noticed, temperature makes a difference. And in part that's why, because when it's hotter, the cell actually is able to work as a self-regaging electrode off of its own potential. So I was able to enhance that obviously by putting the PEG cell at very low, like keep warm in the oven. And just by doing that, you don't even have to, usually when you make an electrode, you have to feed it a DC source. You don't have to do that with the PEG cell because the PEG cell is already providing its own dipole alignment. So you just warm up the PEG a little bit, and that aids in the magnetic alignment, then let it cool down at room temperature, and it'll go up like 0.2 to 0.4 of a volt on its own, which is very interesting because it's a very, a low temperature version of an electret. So these are all extra additional features which I believe would be more suited to exploit the PEG cell for, but not directly as a power source. The same thing putting them in series with DC batteries or sources so you can knock the current down a lot. Several features which I've documented which they would be better for. And there's also a hint at probably anti-gravity projects as well for their unique feature, the polarity inversions. And they're very good at working at high voltages as long as the electrodes inside are spaced far apart enough. Very interesting effects at high voltages. I was able to ping pong a high voltage pulse between a neon and between two peg cells. I don't know if I actually recorded that or not, but that was very interesting. So, yeah, they have a tendency to self-oscillate as well. They carry random AC fluctuations, very much like the John Hutchison cell. I've measured that, demonstrated it, and others have as well, not just me. Others have videos of it shown and on their scope. So I like it when others verify what I think are key points anyways, you know? So, yeah. Just reading here all the comments here. The lab is looking good. Thank you. Yeah, I'm unfortunately I'm already in the mess here because I'm experimenting with microwaves. Um, I'm trying to get a cold reaction out of the magnetron essentially. And I've got my spectrum analyzer in there. And it's not doing anything, but you know, here's the frequency range on my screen of the 2.4 gigahertz band. I've got a 20 megahertz bandwidth span that I can see at one time, then I gotta go up and down the band. So if anything at all pops up in there while I'm experimenting is a good sign of what it is I'm looking for. Because I don't know what my goal is yet, it's just some stuff I found in my new Maxwell equations. Um, I'm not even sure what I'd do if I'd find microwaves out of a cold reaction. I guess I'll save that for step 2, right? But far, far away in my mind, I have an idea of using the ambient somehow, like we do with Bedinis, to trigger a microwave reaction, which could, in a resonant cavity, potentially amplify with resonance and use it as microwave energy, you know? Sometimes we do the wrong thing by trying to convert energy into some other form of energy at the cost of a great loss. Maybe we should try and utilize sources of energy that are easier to create and manipulate and just use it for that. So microwaves, communications, heating, obviously, um, cooking, and there's also thermal pads. But anyways, I'm not there yet, but I just have this crazy idea. Like I say, it's far away, but I believe that maybe, because this works a lot like vacuum tubes, and vacuum tubes do very interesting things when you feed them with zero current, high voltage electrostatic, right? So perhaps, and the thing is, it's highly nonlinear with the microwave magnetron. So there might actually be new frequency ranges. It might not actually be on 2.4 gigahertz, right? It might actually, one of the many resonant, it could be even lower frequency ranges, you see. So there's a lot of experiments to be done here, and something else I found, nice little fan from the microwave. And I like the design because it's clean. And I don't know, not that this would do anything, but it seems like it's really easy to rewind this coil here and turn it into a Bedini. I don't know why I'd want to do that, but it almost feels wrong to leave it like this because it's so inefficient, right? Uh, but yeah. Yeah, 2.4 gigs. The thing is, the microwave actually is actually right in the middle of the ISM band, which is the same thing as our the Wi-Fi, the 2.4 gig Wi-Fi. Not so much anymore because we're moving on to 5 gigs, but when Wi-Fi first started like 10 years ago, that was a common thing. Every time you turned on your microwave, your Wi-Fi devices would go clunk. It was so annoying. I remember it, trying to stream with a tablet, whatever. Someone turns the microwave on, dead. So that's because the microwave is actually on the ISM band and it falls right in the middle of the Wi-Fi. So it doesn't take very much to knock off Wi-Fi, especially when the bandwidth of the microwave hogs like half of the Wi-Fi band in one shot. So, but not so much of a problem anymore, right? Because we moved the Wi-Fi over, totally different band now. But it was such a nuance with the 2.4 gig stuff. So annoying, especially if you just had like a little bachelor apartment. So you don't have much space, right? You're like, wherever you are, you're like 25 feet away from the microwave. All your devices that were wireless would just go out. But the reason too that I like 2.4 gigahertz for experimenting with the Tesla longitudinal waves and scalar waves is because it's much more controlled environment that way. And you don't have all of the negative effects of spurious all over the HF and traditional radio spectrum. So a lot cleaner, much denser as well, much denser energy. And yeah, I mean, it just seems to make sense to try and experiment with this right now, doing what Tesla was doing, but in a more appropriate frequency range that he didn't have access to at the time. You see, it's trying to do everything Tesla did and what we're doing with Don Smith. Don Smith, I'm sure you know the name. Let's apply it with microwaves instead. Just easier, you need a filter. There's already a filter because 2.4 gigahertz is an ISM band. All the Wi-Fi stuff. I need a sensor. I'm using an old Wi-Fi antenna from a router. It's all tuned. You need a resonant cavity. They show you how to build CAN antennas for 2.4 gigahertz. There's a million programs you can run on your phone that calculate it all for you. So by doing it this way, it's a lot more, how should I say this, industrial standard. So you less chance that you might have the right idea, but because you build the resonant chamber wrong, you got the wrong result, so you think it doesn't work and move on to something else. While here, what I'm getting at is why reinvent the wheel when we don't have to do that? When there's already one that's already built for you at specification. So it's just a lot, for someone like me, it just seems a lot easier to experiment with this than trying to build big, huge resonant Tesla coils on the shortwave bands, because the lower frequency, the bigger the stuff gets, right? So, and the more the magnetic field couplings are further apart. So the faster in frequency, the tighter the magnetic couplings become. If you're dealing with electromagnetic, like transformers kind of setups, So a lot of advantage, but again, it depends what you want to do, right? I mean, microwave is not for everything. It's not for everyone. There's still a lot of stuff to learn about the Bedini process, which I still want to do here. I've got a PCB ready, basically. I just need to get it printed. And I want to, if it works well, actually I'm going to have to print like 5, 6 of them because they won't make the order and actually sell those, where users can test their own coils. But that was sort of put on hold there for a while as I was getting all of this stuff ready. And money, of course, And I want to make sure that's right. So I've been upsizing everything, higher rated parts, but that brings up the cost, right? Because you never know what kind of an event you can get in the inductive kickback. It could be quite powerful, especially if you're coupling in with something global that you may not be 100% aware of. That's the whole point. It's an experimental circuit. So if I'm going to push these out for people to experiment with, I want to make sure it could withstand the first significant event that you may get to deal with, right? So getting there, though, that's the nice thing. You can save your work, and when it's ready. The hard part I find is associating everything to their parts database, because drawing the schematic is one thing, simulating it is another. Then you got to do the parts database, the bond thing they call them. And if you're with DigiKey, whatever, then you have to use their stock. And then they usually don't have what it is they're looking for. So, and there's like millions of part numbers. And most of it is all labeled in part numbers, so it's not as easy as writing, 12-volt Zener diode. You need the real part numbers, and half the time they don't have them. So that's what's been taking a lot of my time when I try and build these, is trying to associate the parts that they have. That's not like a rip-off part that they're going to charge me $90 for, right? Because it's a substitute of something that, anyways. But it's in the works. It's in the works. So I'd like to experiment with that, the dual MOSFET switching, so the system could self-recycle its own energy. It just seems to make sense doing it that way. I mean, never mind isolation losses, conversion, transduction, no. Just direct the whole flow. It's the equivalent of pushing the ball going downhill, essentially. So let's do that, right? And then if that works, move on to multiple coil systems. But one thing at a time, folks, right? One person can only do so much. And I'm trying to keep everyone up to date, and I'm trying to do this live format here more because it seems to work. So with that said, folks, I'm gonna, I guess, wrap it up for now. Just my update as I can. And I will see you all later as soon as there's new information to share, and I'm always around to interact. And again, thank you all for watching and your interaction and your support and sharing the links and your interactions and everything else. I've got the form as well, typewrite.social, typewrite.social. It's my Maxwell wiki, which leads to the forum. A lot we can interact on there anytime. So with that said, folks, again, have yourselves all a wonderful day, and thank you all.